In this video, we're looking at how do we analyze the motion of an object in free fall. And we want to start by defining what is free fall. So during free fall, an object is only under the influence of gravity. In other words, there's no other forces acting on the object if it's defined as in free fall. That means that there's no or minimal air resistance or any other forms of propulsion. This means we are not talking about airplanes because they have engines. We are not talking about birds because they can flap their wings and have other forms of propulsion. We are not talking about parachutes because they have a lot of air resistance. We're not talking about pieces of paper or feathers because they have lots of air resistance. Instead, we're talking about things like footballs and baseballs, dropping different rocks and things like that. Now, if an object is under free fall and the only influence is gravity, that means it is accelerating at a rate of -10 meters per second squared. Now, what that -10 meters per second squared represents is it represents that the velocity goes down by 10 meters per second every second. Again, another way of writing this is -10 meters per second. So it's saying the velocity goes down by 10 meters per second every second. That's why the seconds is written twice. We a lot of times abbreviate that with the number 2 as a square. So what we see here is a visual. If we drop an object, that means that the velocity starts at 0. And as you drop it, the velocity goes down by 10 every second. Therefore, after 1 second, the velocity goes down to -10. After another second, it goes down to -20. After another second, it goes down to -30. After another second, it goes down to -40. So every second, the velocity decreases by -10 meters per second. Now this is nice, but what if we don't drop an object but throw it upward? Now if we throw an object upward, the acceleration is still -10 meters per second squared. So therefore, the velocity is still going down by 10 meters per second every second. So let's say we throw an object upward with a velocity of 30. After a second, the velocity goes down by 10, it goes to 20. After another second, it goes down by 10 more, it goes to 10. After another second, it goes down by 10 to 0. So we see that at the top of the trajectory, and trajectory is the path that the object takes. At the top of the trajectory, the velocity is 0. But it doesn't pause there. I've never seen yet where I throw an object up in the air and it stops at the top and stays there. The velocity continues to go down by 10. So after another second, it goes down to -10. Now the negative simply means that it is moving downward at 10 meters per second. After another second, it goes down again to -20. After another second, it goes down again to -30, and so on and so forth. And what we see here is that if we're at the same height, then the two velocities are the same, except the final or second one is negative. So at the same height, the two velocities are the same. It is just that the second velocity is negative. Again, at the same height, the two velocities are the same. Only the second one is negative. So now what we want to do is we want to go over how to solve some problems that involve this idea of free fall. And to do so, there are 4 different equations. I'll list them as 1, 2, 3, and 4. Now in these equations, we have d, which represents the distance, and that is measured in meters. We have t, and that represents the time. That's measured in seconds. We have v, that represents the velocity, or speed, and that is measured in meters per second. And then we have a, and that is representing the acceleration. That is measured in meters per second squared. Now notice that there are two velocities because, remember, during free fall, the velocity changes. We're going to go through two problems together, and I'll show you how to pick what equation you're going to use. And then we are going to solve here. So the first one says a stone is dropped from the top of a balcony and takes a time of 2.3 seconds to fall. What is the speed of the object after 2.3 seconds? Now the first thing we want to do is we want to write down the numbers that we know. Clearly, this 2.3 seconds represents either a D, a T, a V, or an A. It says a time of 2.3 seconds. So in this one here, we know that that is the time. It is 2.3 seconds. We then look at the word dropped. And the word dropped represents a number. When we drop something, it starts at a speed of 0. So whenever you see the word dropped, it means that the first speed is 0. The last number that we know is from just its moving through the air. We said when an object is moving through the air, it accelerates at -10 meters per second squared. So our acceleration is -10 meters per second squared. We want to figure out what is the speed after 2.3 seconds. So what is the speed after? That means that we are looking for v2, the speed at the end, after. Now notice here that we are not having anything with the letter V. I'm sorry, the letter D. So I'm going to cross out the letter D. Everything else either has a number or a question mark. And it's very important to write the question mark on which letter you're looking for. So when we're figuring out what formula or what equation to use, what I'm going to do is I want an equation that does not have the letter D. I want an equation that does not have the letter D. So if I look through here, equation 1, 2, 3, and 4, this one has a D, this one has a D, this one has a D, this one does not. I'm looking for the equation that does not have the letter D, because that's the one that I don't have anything written next to. So I want to use that formula, the first one, when I'm solving. Now if I look here, in place of the letter T, I'm going to write 2.3. In place of V1, I'm going to write a 0. In place of A, I'm going to write -10. My V2, since that's my question mark, that'll stay as a V2. And at this point, I can solve. This is simply 0 plus -10 times 2.3 is -23. If I take 0 plus -23, that is -23. So my answer becomes -23, but we do need a unit. I was solving for a V, so if I look here, a V is a meter per second. So my second velocity is a -23 meters per second. The negative simply means that it's going down. Now in this next problem, we have a baseball is thrown upward, straight up into the air with a velocity of 13 meters per second, and it is caught at the same height as it was thrown. How much time is the ball in the air? And the hint is you should know V2. So I'm going to take this ball, throw it up in the air, and then it comes back down. First we have the 13 meters per second. And it says a velocity of 13 meters per second. So that is our first velocity. Now the hint here is that you should know V2. And the reason we should know V2 is because it says the same height. We wrote down in our notes that if we're at the same height, they are the same velocities, only the other one is negative. So when it's the same height, the velocities are the same, only the second one is negative, whatever the first is. Now we're always going to know three numbers, and the third number comes in the form of acceleration. Whenever an object is moving through the air, we know that the acceleration is negative 10 meters per second squared. So again, whenever an object is moving through the air, the acceleration is negative 10 meters per second squared. Next, we want to write a question mark, and what we're trying to find, it asks how much time is the ball in the air. So we are looking for t. That means that we don't want the letter D at all. So now as we choose our equation, we see again that we're going to use the first equation here, the one that does not have the letter D. Now this time, in place of V1, we're going to write 13. In place of V2, we're going to write negative 13. In place of A, we're going to write negative 10. This one's going to require a little bit of algebra. Now in algebra, the main idea is to move everything without a letter attached to the other side. And then we divide by the number next to the letter. And by letter, I mean the variable. So again, we want to move everything without a letter to the other side. So the 13 does not have a letter connected. I'm going to move it to the other side by subtracting by 13. Here, 13 minus 13 just goes away, it's 0. Negative 13 divided by negative 13 is negative 26. We are left with, on the right-hand side, negative 10 times t. Then we divide by the number next to the letter, or variable. So right now we have a negative 10 next to the variable. So I'm going to divide by the negative 10. We always divide by the number next to the variable. Here we're left with t, and negative 26 divided by negative 10 comes out to be 2.6. So our time is 2.6, but we do need a unit, as always. Since we're solving for a t, the unit of time is seconds.